We now describe the vector nature of Newton's second law of motion. When subjected to a net force on a friction-free surface, an object accelerates with an acceleration of a equals F divided by m, where the acceleration is in the same direction as the force. If we look at this same scenario from above, we see that the object accelerates in two dimensions, in a plane. If we place the force vector at the origin, we can, through the same methods used to find the x and y components of any vector, determine the x and y components of the force. We can then apply Newton's second law to the force's components to get the x and y components of the acceleration. If we need to determine the resulting acceleration of two forces acting upon the same object of mass m, we must first add the vectors to find the net or resultant force, Fr. The vector sum of the forces is equal to the mass times the acceleration. Again, the vector addition can be done using any of the methods you have learned. Once that vector sum, i.e. the net or resultant force, has been determined, the x and y components of the resultant force, and therefore of the resultant acceleration, can be calculated. When two or more forces act upon an object, one can instead determine the x and y components of each and then add them to find the x and y components of the resultant. These vector concepts are identical to those you needed to apply when analyzing projectile motion. The important concepts to take from this section are: 1. Force and acceleration are vector quantities and must be treated as such when applying Newton's second law. And 2. Newton's second law can be applied separately to the sums of the x and y components of the sum of the forces in order to determine the x and y components of the resultant acceleration.